Today I'd like to teach you how to get a linear regression from two sets of data using Google Sheets and a TI type calculator. My experience has shown that this is the kind of calculator that students are most likely to have, and Google Sheets is free and online to everybody, so that's a pretty good baseline, I'd say. Besides, Google Sheets operates pretty similarly to other spreadsheet programs, and like I said, it's free and online. So let's get started. First thing you're going to need is some data. So I've got some data entered here, and the first step with the data is to make a chart out of it. Now there is a shortcut to make a chart in this row of buttons, but my face is covering it. So if you go to the insert menu, you'll see chart here. Now I've got two sets of data. I'm expecting to get a line out of them, and when I press chart, I'm very disappointed. It looks like I've got a bar graph, two bar graphs for some reason. What's going on? Well, you see, computers are very good at doing menial, tedious tasks, but they are not very smart at figuring out what you're doing. I didn't supply the computer with enough context for it to figure out what I'm doing. So I could do it manually, or I could just supply the context so the computer knows what I'm doing. I'll do it both ways so you can see how it's done. First of all, you can see the first 10 rows of column A and the first 10 rows of column B are both being treated as series of numbers. Actually, I wanted column A to be kind of like X values and column B to be like Y values. So there is a space for an X axis here. If I just select these A values and remove them, and then the X axis, choose them, now I've got A as X and B as Y. However, it still is making it a column chart. I don't want that. Give me a scatter plot. So if I scroll down these options under chart type, I see scatter. There we go. That's what I want. All right, well, instead of having to force feed all that information to Google Sheets, what I'm going to do is I'm just going to be a little bit more contextual with these. So if I insert a row here and just call this X and call this Y, right? Like I was actually making a table that I intended someone to read. Okay, now let me try this again. I'm just going to select this table, including the headers, insert a chart, and look at that. It already knew what I was trying to do because of the context that I gave it. Okay, so what do I do with this now? First thing I'm going to do is zoom out so you can see the whole thing. There we go. All right, so this chart, based on this data, I'd like to get a linear regression. How do I do that? Well, the way that I do that is I just get out of my own way a little bit. You see here it says customize. Well, customize has series under it, and under series I can do some things with my data series. Like change what color it is and all that sort of thing. Maybe change the size of the dots. This is where you can edit your graph. Well, because I'm dealing with my series of numbers, one of the things that I can do is get a trend line. So if I click trend line, there you go, it draws a line through the points, and that would be the line which is the subject of the linear regression. However, I want the equation for the line. I'm trying to find, not just draw the linear regression. So under label, I can choose use equation. And there we go. That is the equation that I was looking for. So thank you, chart editor. I no longer have need of your services. If I was looking for a function to describe these points as closely as possible, I've got one in f of x equals 1.49x plus 0.529. And that'll do pretty nicely. Thank you, Google Sheets. You've been very helpful. Now what I'm going to do is I'm going to show you how to get this same thing, but using a graphing calculator. So let me just switch my view here real quick. Oop. All right, good. So as I said before, here's your typical graphing calculator. I'm just going to be using this old TI-83. You probably have a newer one. That's okay. I'm not jealous. So if I turn this on, the menu where you're going to get these capabilities here is called STAT. That's short for statistics. This is where you can enter lists of numbers and find out interesting things about them. So you want to edit this. So under edit, you'll see the first option is edit. So you can just press enter. You can see here I've got some of the numbers already entered, but I want to make sure that I show you how to enter them, because this interface is it's not the best. So I'm going to use the first list, L1, as my X values. I'll put my Y values here in L2, and you just have to enter the number 3.3, and then you can hit enter, and then it's entered. Entering this, I don't know, maybe this is just me, always seems to be a tedious and error-prone procedure. I like to type numbers on a keyboard, if you can believe it or not. So entering them like this, for me, I just so nervous that I'm misentering things. Anyway, I think I did that okay. So I've got L1 and L2, both containing the lists of numbers that I had in Google Sheets just a moment ago. So if the interface is tricky, that's totally evened out by the fact that the next process is so simple. How to get that linear regression? Well, press Stat again. Previously, we've been editing the lists. Now we're going to make some calculations from the lists. So if you press the right arrow key, you get this Calc menu. And these are all the different statistical analyses that the calculator can do based on those lists of numbers. What we want is a linear regression. So you go to option 4. You can actually just choose it by pressing 4, but I think it, just looks a little better scrolling down to it and hitting enter. I'm doing this for you. Hit enter, it puts it in the main screen. It's like, hey, you want to do a linear regression, right? Slope-intercept form, ax plus b, where the slope is a and the intercept is b. So hit enter, it thinks for a second, and there we go. All right, so as you can see, this gives 10 digits by default. Totally unnecessary amount of precision, but 1.49 rounds down to 1.491 rounds down to 1.49, and 0.5285 rounds up to 0.529. So as long as we don't need 10 digits of precision, we actually have the same regression as we got from Google Sheets. They are essentially in agreement about the linear function that relates those two sets of data. Okay, cool. So now we've got these functions, well, this function that describes these two sets of data. So what? What do we do with that? Well, a linear regression, a function, is oftentimes a great model for some sort of physical process that gives us these real numbers. So you might want to take this function, say, and put it into a graphing application, like Desmos, or again, your graphing calculator. And what do you do with it? Well, you can extrapolate with it. I've got all the way up to about 20. What if I wanted to go up to 30? Well, if you went up to 30, you'd be getting numbers somewhere in the neighborhood of like 45, or something like that. That's extrapolation, going outside your data set, predicting other values. You can also go between values. You can interpolate. I went straight from around 10 to around 12. If I was here at 11, I could expect something like 16.9. Okay, something else that's really beneficial about having a linear regression is you have this equation. Let's say I had some physical quantities that these numbers are based on. Maybe I'm measuring the position over time of some object, right? So x-axis, independent variables, usually time, and so that means that the y-axis, the dependent variable, would be position, something like that. Okay, well, this linear regression, this function, gives me terms that I can interpret. If the y-axis is distance and the x-axis is time, then that means that the slope here would be a rise over run. That would be a distance divided by a time. Distance divided by time is velocity, so I could actually interpret this slope as an average velocity. Not only that, but the y-intercept is the y position at x equals 0, which means I could interpret this to be a starting position, like a head start at time equals 0. It was likely at position 0.529, and then it proceeded from there with an average velocity of 1.49. That's a legitimate physical interpretation of this linear regression, which is essentially now serving as a model for whatever physical process I've collected data on, and using it I can extrapolate, interpolate, and do all sorts of other mathematical sciencey goodness. Anyway, that is how to get a linear regression using Google Sheets and a TI type calculator. You might be doing this for science or for math, or because your teacher told you to when you're in school. Anyway, now that you got the tools, go and do it well.